There are several different techniques for sharing data between processes. One that you're familiar with at this point, hopefully, is the multiprocessor queues. A multiprocessor queue allows us to have a common data structure where we can place data in at the front of the queue, and then we can start pulling data out at that same end, so first in, first out. And there's no restriction as to how many different processes can access this queue. We tend to use the queues in the producer-consumer design pattern, but that is not the only one we can use. Now, another technique is to use something known as a multiprocessing pipe, or just pipes. A pipe, if you think about it in terms of plumbing, allows you to transmit fluid like water from one end of the pipe to the other. And we can think about these as endpoints. Okay, so one end of the pipe is one endpoint, and at the other end of the pipe is the other endpoint. Unlike traditional plumbing pipes, however, multiprocessing pipes can be bidirectional, and by default they are. That means you can transmit the data on one end of the pipe to be received at the other, so end A sends to end B, or you can send data from point B to point A. So both directions are legal. The only thing you can't do is send data on one end of the pipe multiple times at the same time. So only one thing can be pushing data into the pipe at any one time. Pipes are also the beginning to distributed programming, whereas right now we have our processes are working sort of in the same program. Even though we're spawning multiple processes, there's also the technique of having completely separate programs, possibly on completely separate computers, all talking to each other. And pipes are one way we can accomplish this goal. However, that is beyond the scope of our demos, but I'm just pointing it out to your attention that we are basically heading in that direction. So let's get started looking at how pipes work. We are going to use the multiprocessing module again, and we're going to import process, and this time we're going to import pipe, not queue. And we're also going to import sleep, and then we are going to do the same debug configuration that was done in the queue demo, where we are going to import from the logging module, and we're going to call basic config, and we're going to configure it for debug level calls. So when we call the debug function, it's going to format it in this manner where it's going to show the process name in square brackets followed by the message that we're trying to print. And we're going to define some constants here. Well, not really constants, but we're going to use them as such. And then we have our max items, so that's the number of items that we're going to be transmitting. And then we're going to have a poll timeout. I'll explain what poll means in just a second. And then we're going to have a sleep length. Again, we're going to have our different processes take a nap so we can simulate longer running code. Now, I mentioned we have this thing called a poll timeout. Well, when we are sitting on one end of the pipe, we want to know whether or not there's any data that's coming through the pipe right now. And one of the things we can do is use a command called poll, which will allow us to wait for a certain amount of time to see if any data arrives. And if data arrives in that given amount of time, we can go ahead and process it. Otherwise, we are going to move on and said, no, there was nothing turned on, the spigot wasn't opened, so we have nothing to process. Now, I'm using this poll timeout as a counter so we know how long we want to wait, or how many polling sessions we want to do before we really give up. Because we may want to poll for a second or two at a time, but we don't want to lock up this thread necessarily. So we may say, okay, well, we tried, let's move on, and then we'll get back to it again, and we'll try again to see if there's any data. But I'll show you that as we start working on the main program. Again, we are going to want to check if name is main. If it is, then we want to start up our processes. And we are again going to use the debug command to do our output. So we'll say setting up pipes. And then we are going to create our pipe. As I mentioned, a pipe has two ends. It has the sometimes known as the producer end and sometimes known as the consumer end. Remember, this can be bidirectional, so it doesn't necessarily have to be producer and consumer. But we're going to do the simple producer-consumer example and demonstrate what this looks like if we were to treat this as a monodirectional or unidirectional pipe instead of a bidirectional one. Okay, so we are going to create our producer connection or endpoint and our consumer endpoint. So we're going to call them producer con and consumer con for connection con. And we're going to create them off of the pipe initializer. Then we're going to create our processes. When we create our processes, we are going to create a producer and a consumer. And on the producer process, we're going to pass it this end of the pipe, the producer connection side. And when we create the consumer, we're going to pass it this end of the pipe. So let's create our producer. We'll call it prod. And again, we're just going to launch a process and give it a name. And the name will be producer. Our target will also be called producer, which we have yet to create. And our args are going to be a tuple, and the tuple will consist of only producer connection and a comma. Our consumer process is going to be written in much the same way, or at least how we launch it, except we're going to name it consumer and the target is going to be consumer, and we're going to pass it the consumer end of the connection. So those represent our two processes. Then I'm going to create another debug command here to indicate we're starting our pipe processes. And then we'll kick them off. I'll say producer.start or prod.start. And then we'll say con.start. And I'm going to put another debug statement here, waiting for threads, or sorry, let's wait for processes. I know I tend to use the names threads and processes interchangeably, and a lot of people will say, hey, that's fine. Sometimes I try to be a little bit more of a stickler. And a process really is different than a thread, even though what we're really talking about is spawning a separate thread of execution, not necessarily a thread object. It's a thread of execution, which means we have two different paths of execution that are happening, hopefully simultaneously. So the pipes process is complete. Now you'll notice here I only joined on the consumer. Yes, we could join on both producer and consumer, but the way I'm setting it up, the producer is going to finish what it's doing and it's going to close its connection, and I don't have to wait on it. It's the consumer that we have to wait on because it's the one that's going to be hanging around longer, and we want to make sure that we don't end our program before the consumer is done doing what it needs to. I'm going to minimize the terminal for right now. Let's go ahead and define first our producer. And in our producer, we're going to have our pipe connection. Remember, it's just one end of the pipe. And then we are going to loop for I in range max items, and we're going to produce these items. Okay, so I'm going to say debug producing data, and then I can use the send command. Now the only restriction as to what I can send is that it must be pickleable or serializable. Pickleable is a term that's commonly used in Python to indicate it has the ability to be serialized. Serialized means we can take whatever object we're trying to send on the pipe and convert it to wire format. In other words, instead of being a collection of different items, it will actually convert that into a single stream of data that can be sent down the pipe, and when it's received on the other end, it can be reconstituted back into its original form. Now you can look up pickling on the internet and get more background on it. Just be aware that all of your default types are pickleable. Okay, there are a few that you might have trouble with, like you're not going to want to necessarily send like a pipe down a pipe, because there are some other pieces of information in the pipe itself that cannot be transmitted and successfully reconstituted on the other end. But for the most part, anything like strings, lists, and integers, all of those can be pickled and or serialized. Okay, so what are we going to send? Let's go ahead and send a list. And it's going to consist of the index that we're currently on, so 0 through max items minus 1, and then some string message. And it's going to be formatted, so I have the F string, and I'll say message number I. So nothing too fancy here. We can send whatever object we want as long as it is pickleable. And don't worry, if it's not pickleable, you will get an error telling you that you can't do it. And then there's plenty of activities online where you can walk through them and figure out how to make objects pickleable. Just be aware, as long as your data is simple and that's all you care about is the data, then you're not going to have any problems doing it. Integers, like I said, and decimals, doubles, all of the standard data types can be. Okay, and then we're going to sleep for a given length. So we're not going to just spam all the data into the pipe at once. And then I'm going to debug, and I'll say done producing data. And then we're going to close our connection. Closing the connection is always a good idea because we don't want to keep these pipes open indefinitely. There is a scarce resource on your computer known as ports, and anytime you start doing connections like this, you are utilizing possibly some of those limited resources. So as soon as you're done, it's always best to close it. And make sure that's a parenthesis and not a 9. And then we are done with the producer. Now, the one thing I am going to do is I'm going to take this message and put it outside the for loop. I just don't think I need to see producing data every time we're doing that, but I would like to see possibly sending message, and then we'll put an I, and then I'll put an F in front of it. Okay, that I do want to see, and I will indent it a little bit so it'll stand out from the rest. Okay, that's good. Now let's define the consumer. And again, it will have its own pipe connection. It's different than the pipe connection in producer. It's the other end, because remember, we sent them as the arguments, producer connection and consumer connection. Okay, so we're defining the consumer side of things now, and let's also put a message in here, consuming data. And I'm going to create a variable called poll count, and I'm going to make it equal to poll timeout. So this is going to be how many times we wish to poll before giving up and exiting the method. We don't want to sit here and wait forever. We're going to try to read data in a reasonable amount of time, and if it doesn't come back in that amount of time, we're going to give up. That being said, we're going to make a loop where we're going to try to read the data. And we're going to have a try and except. Let me put some passes in here so the code won't complain. And what we're basically going to do is if we hit any kind of exception, we're going to assume that the pipe is dead. Not necessarily the best assumption to make, but in this program, because it's so simple, that's really the only thing that's going to be happening here. So we'll say producer pipe broken. And we are going to break out of our loop. So we'll break the while loop, the while true. Now try. This is where we're going to do all of our work. So let me get another debug statement in here. And we'll say looking for data. And then we're going to check to see if there's any data to read. So we're going to ask the pipe connection, do you have any data? And what we just did here is we said the pipe connection, this end of the pipe, we're going to poll for data. In other words, we're going to sit here and wait for 1 second for data to arrive. If this poll returns true, that means we have data to read. So then we can issue the receive command, which is recv, and that should be an equal assignment. My apologies. Okay. Then, after the receive, we can print out what we received. So I'll just copy debug here. I'll say received, and then whatever data we received. As long as it was able to be deserialized, we should be able to see it. And then I'm going to reset the poll count to the poll timeout. So that means if we have received data, then we have to assume that we are making good connections with our other end of the pipe, and let's restart back to the poll timeout. So if poll timeout ever gets to 0, that's when things are going to happen, that we're going to quit. So we'll say if, then we have our else. So if we were not able to retrieve any data, then what we're going to say is poll count minus equals 1. If poll count is less than or equal to 0, break. And that should be a minus. Okay, so make sure that if we get to this part where we weren't able to poll for data, then we are going to decrement the poll counter by 1, and if the poll counter ever gets equal to or below 0, then we have to exit the loop, which will in turn exit the function completely. And right now, that should take care of our consumer. Oh, I forgot the F. So that data was complaining because we never used it, and that's because I forgot to put the F, which would make this an F string or a formatted string. Okay, so let's relint it. There we go. Okay, what I just said, I relinted it. That just means I saved the file, and the linter will run, which checks the syntax. As long as we don't have any squigglies here, the little, like the red underlines or yellow underlines for errors and warnings, I think we're good to go. Okay, so let's go ahead and make the terminal window a little bigger. and then we will say Python mp pipes demo.py, and as long as we wrote everything correctly, you'll see we're setting up pipes, starting the pipe process, waiting for the processes, and then producing data, sending message 0. I need to make this bigger. And then looking for data, received it, looking for data, looking for data. Every time it waits, that's what it says, is looking for data, looking for data. Okay, and then when it finally receives data, so poll comes back true, then it pulls the data out and says received. Continues to look for data. The message gets sent by the producer, the consumer receives it. Looking for data again, looking for data. While it's looking for data in this poll, the producer sends another message, and then the poll comes back. Here's the data from that one. And then finally we get to the fourth one, and it's been received. It says looking for data, looking for data. We slept the 2 seconds, and then the producer is going to say, I'm done. I am no longer producing any data. But the consumer has a timeout of 10, essentially. So it does a poll for 1 second each time, right here. Oops. Does a poll for 1 second each time, a total of poll count times, which starts at 10 and subtracts 1 every time. So we should see after 10 seconds when we have 10 of these polls. 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it gives up and it returns back to the main process. That's where the join will finally catch up and the pipe processes are complete. So again, pipes are just another mechanism for communicating between two different processes. This one is a little more tricky than the queuing techniques because you have to be very careful about how you're putting data in the pipe and making sure the data is able to come out of the pipe at roughly the same time. You don't want things piling up in the pipe too long, and you also don't want to be pushing data into a pipe simultaneously for multiple processes. We know that's a bad thing. It's okay for you to send on one end and send on the other at the same time, that's fine. But you just don't want to be sending at the same time on the same from the same end. That messes things up. And think about it this way. If you were to have a pipe on one end with a manifold, so you have that splits into two pipes, and one puts in red water and one puts in blue water. If you put the red water down the pipe, you get red out the other end. If you put blue down the pipe, you get blue out the other end. But if you open up both of them at the same time, the water is going to get mixed, and now you're going to get purple. And the last thing we want in computers is for our data to get corrupted by mixing it like that. So there's a good reason for that. Anyway, so pipes are another technique you can use to communicate between processes.